Good morning students. Here in this video we will start from question number 3 of exercise 10.1. If you see the book, in the book the figure is given and the conditions are also given that AB equal AC. Here this AB equal AC and AP is equal to AQ. This AP is equal to AQ, and we have to prove that this APC, this triangle APC is congruent to triangle AQB. That means this triangle, those two triangles, those we have to prove congruent, are of different color. Here you can see easily and identify those two triangles that we have to prove as congruent triangle. So see the parts that are given equal. AC, that means this part of this triangle, okay, this orange colored triangle is equal to AB, that means the side of this yellowish color triangle. So this AP is also equal to AQ. This AP of this triangle is equal to AQ of this triangle. Then two sides are equal, to corresponding sides are equal, okay, for those two triangles, and one angle which is common for both, that is angle A. So the angle APC contains angle A and the angle AQB also contain angle A. Then we will say that there are two sides equal and two corresponding sides are equal and one angle is equal. So by the side angle side rule we can say this triangle APC is congruent to triangle AQB. So those two triangles are congruent. Those two triangles are found congruent to one another. And if they are found congruent, then we will say that the congruent part, the corresponding part of the congruent triangle, that is CPCT, the CP, one of the side of this APC. Okay, this APC has the side CP, this CP. Okay, this CP is equal to BQ, that is the one of the side, the corresponding side of this triangle AQB, that is this BQ. Okay, so CP is equal to BQ. This is the corresponding part, the corresponding side of the triangle, of the congruent triangles. And one more angle is also equal here, APQ. This APQ, that means this angle, okay, this angle APQ must be equal to this angle at Q, okay, because Q is the corresponding point of P and Q are the corresponding points I'm telling. So APQ is equal to AQB. So those two angles are also shown equal. Now see the next question number 4. For question number 4, the solution is not given but the hint is given. In the question it is given that AB equal to AC and AP equal to AQ. So if this AB and AC are equal and those are added with the two parts, that is AP, which is equal to AQ. So we can add those, because this AB equal to AC, this AP equal to AQ, and whenever those are added we will get the complete side BP and this CQ. Now you can use this BP and CQ, those are equal. You can use those equal sides, equal corresponding side of the two triangle, and try to prove them congruent. Okay, you can. So you can use this. Now see the solution of question number 5. In triangle ABD and triangle BAC, you can see here we have a, see here we have the rectangle ABCD, okay, and as it is written, it is given here AD equal BC. Okay, so see, in this question the actual question is to be proved is given here. Okay, we have to prove that ADB equal to BCA and this DAB is equal to CBA. So in order to prove those angles equal, we have to prove this ABD is congruent to BAC. So that's why the solution is started by considering ABD and BAC. Remember that. Okay, whatever we have to prove by the that means whenever we show that we have to prove this, then we have to use the idea that we have to go start with those two triangle and prove them congruent. Then after we are able to prove those as equal angles. Okay, so that's why I have started with this line, that triangle in triangle ABD and triangle BAC. So this one is the triangle ABD, I'm sorry, this one is the triangle ABD, this orange color triangle, and this one is BAC it is, okay, ABD and it is BAC. So AD is equal to BC is given, AD equal to BC is given. Okay, so if we are and one more thing, this is also given, BD equal to AC, BD BD is equal to AC. So BD is the corresponding side. Will become the corresponding side of AC. So whenever we take BD, we have to take AC. So that's why it is written ABD. So in the place of BD, it is BAC. Okay, like that. So, and one more thing, that is AB is equal to BA. AB means AB or BA, you can say, or in reverse. AB in reverse, it is BA. So whenever we are saying triangle ABD, so the length is taken as AB. Whenever we are saying BAC, the length is taken BA, but the length is equal because they are common side, because this is the common side. So we got the three equal sides. So we can say by the side criteria, the angle ABD, triangle ABD is congruent to triangle BAC. Then the corresponding parts are also equal, that is the corresponding angles ABD. This ABD, that means this angle is equal to BAC. BCA, ABD. Okay, ADB, it is ADB is equal to BCA. That means those two angles, this one angle and this angle, these two angles are the corresponding angles are taken as equal. Okay, one more thing that we have to prove, DAB. So this one is DAB. So this angle is equal to CBA, this angle. So those two are also the corresponding angle. Okay, so those two are proved equal whenever we found this ADB is congruent to BAC. So this is proved. Now see the question number 6. The hint is only given. Whatever the given condition in the question, you can use the SAS criteria. That means two sides and one angle are given equal for those two triangles that you have to prove congruent. Okay, so you can proceed to solve this question number 6 by your own. Now see, this is question number 10. I have skipped question number 7, 8, 9. This is only because hints are given and you should try those to solve by your own. Okay, now see the question number 10. The solution is given here. It is given that D is the midpoint. Okay, D is the midpoint of BC. So if D is the midpoint of this BC, then you can easily say that this BD must be equal to CD, because if D is the midpoint, so from this end it has the same length. Okay, so this CD is equal to BD, that is I have written. So this is one of the given condition that we can consider. Okay, now see, the first thing we have to prove that ABD is congruent to ACD. So that's why I have taken ABD, triangle ABD and triangle ACD, and those two triangles are colored different color. Okay, they have different color here. You can easily identify those two triangle. So this AB is equal to AC, it is given in the book as the given condition in the question, and this BD is equal to CD, this BD equal to CD, that we have found here as D is the midpoint. Okay, then one more thing is that this side AD is common for both the triangles. So we have three equal sides. If this is common, then this is also equal. Okay, so AD equal to AD, then we have three sides equal. So by side criteria, we can say that this triangle ABD is congruent to triangle ACD. Then the corresponding parts are also equal. See, then CPCT, that is the corresponding part of congruent triangle, that is the angle BAC is equal to angle CAD. Angle BAC, okay, this angle I am talking, is equal to angle CAD, that means this angle. Okay, this CAD means this angle. So if those two angles are equal, that means this line BD actually divide this angle A. This line AD divides this angle A into two equal halves. So this AD become the bisectors. This AD is the bisector of angle A. This is also proved. This is given in the bit 2. Now for the third bit, again we use CPCT. That means by the congruent part of the corresponding part of the congruent triangle, the angles are equal. Here if you say this angle, see, these two angles are equal. Why? Because those two are the corresponding angle. Okay, so ADB, angle ADB equal to ADC, and as this BC is the side, is a side, that means it is a line. So the line here, the total angle is 180 degree. So that means directly we can say this part and this part, when those are added, you will get 180 degree. So that means this ADB, that is this angle, is added to this part you can easily understand. See this part, then those two angles are added as 180 degree. Clear? So as those are equal, so we can take those as x. Okay, now see in the next page, when those are taken x, see here in the first line you can easily see. Okay, let me show. Yeah, here see ADB plus ADC x plus s equal to 2x. So you will get x equal to 90 degree. X means ADB or ADC. So both are 90 degree. That means directly you can say AD is the perpendicular on BC. See, if those angles are 90 degree, so that means this is the perpendicular on BC. So this is proved. Now see the next question, question number 11. Here you have this figure, this type of figure. See, by the color you can identify the four different triangles. Okay, two triangles are of blue color and two triangles are of white color, suppose. Okay, so given condition is that AB and CD are the two lines, those line segment, those bisect one another at the point O. Bisect, that means divide by two equal parts. So here this AO is equal to BO. See, you can easily say this AO equal to BO and this CO equal to DO, because this O is the midpoint for both the lines, because they are bisect at the point O. Now whatever we have to prove, see, we have to prove that this AOC, okay, this AOC, let me see, this is what we have to, AC equal to BD, this is the first bit that we have to prove. Okay, so if we want to prove this AC and this BD equal, then we have to prove this triangle, this white triangle and this white triangle congruent. So use the idea, whenever we have to prove AC equal to BD, we have to prove those two triangles congruent. So we should start with that line. Okay, so we start in triangle AOC, that is, okay now, sorry, this is AOC, okay, and triangle BOD, this is BOD. Now what are the things that are equal here? See, AOC, this angle AOC and BOC are vertical opposite angles, so those are equal. And one more thing that you may not forget, that uh, AO is equal to BO, so AO is equal to BO, so one side is given equal, and the CO is equal to DO, the other side is also given, and one angle is also equal. So you can directly say that those two triangles are congruent to one another by the side angle side criteria. Okay, because one line, this side AO is equal to BO and this OC is equal to OD, so you can directly say that, see, triangle AOC is congruent to BOD. So when we say AO, it is BO, when we say OC, it is OD. Okay, so equal, and the angle is also equal, this vertical opposite angle, these two angles, okay, this and this. So by side angle side, those two triangles are proved congruent. So in the same way, if we proceed the same way, we can also prove that AOD, these two blue colored triangle, those two triangles are also can be proved congruent. Okay, now you can easily understand those two. Okay, you can use the same things that we have used, and you can use the same criteria, and you can prove those as congruent triangle, those two blue colored triangles. So see, the first bit that we have to prove, as we have found AOC is congruent to BOD, so the first bit AC equal to BD is also proved. And also we can say by CPCT, okay, that means the corresponding angles are also equal. CAO is equal to DBO, that means CAO, that means CAO, this angle, okay, this angle is equal to this angle, so this one is CAO is DBO, see, DBO, CAO is equal to DBO. But here you can see, if this O is on the same line, this O is on the line AB, so in the place of CAO we can write COB, and in the place of DBO we can write DBA. Okay, so see, this O is replaced first by B and this O is replaced by A, so we can say CBA is equal to CAB is equal to DBA. Okay, or ADB we also can say. Clear now? Okay, so this is the second bit that is proved. Now, as I have told that similarly AOD is a proved is a taken congruent to BOC, like those two blue colored triangle AOD is equal to BOC. Okay, so AOD is equal to BOC, and in the same way we also can say this ADC equal to BCD. Like here we have proved like this. Okay, like the same way these two things are proved, then from those two we got those two. So like the same way if we proceed we will get ADC is equal to BCD. You have to proceed in the same way that we proceed like for the two white triangles. Okay, for those two triangles the way we have proceed, you can proceed in the same way and got those for those two triangles. Here you will get this ADC is equal to BCD like that. Okay, see this ADC, that means this angle. Okay, this part is equal to this part BCD. Okay, those two triangles, this one this and one here this. See this triangle and this triangle. Okay now, so if those two triangles are equal, those two triangles are actually the alternating angles. Okay, and this one is the transversal line and those two are the lines, so those two definitely the parallel lines, because if this one is the transversal line and we will find that here the alternative angles are equal, then we can say those two sides are parallel to one another. So we will say that this AD is parallel to CD. So finally it is proved. Now since this AOD is congruent to BOC, okay, then by using the idea of CPCT, that means the corresponding part of congruent triangle are also equal, so this AD is taken as equal to BC. So all of the parts, all of the 4 bits are proved here. Okay, now question number 12 I have not solved, only the hint is given that you can equate the corresponding side because you have two triangles and those two triangles are congruent to one another. So first just give a line that those two triangles are congruent, and then after equate those sides you will get the values of x and y. So this is it. Thank you class, have a nice day.